lesson is the last one in chapter 6, and we have word problems still, but this one is the sum and difference formulas, which are actually all the formulas between the Pythagorean theorem identities and the y equals and cos equals. So these are the sum and difference, the sine A plus B, sine A minus B, cos A plus B, cos A minus B, tan A plus B, tan A minus B. And then these are the double angle identities, the sine 2x. So we are just going to use these, being able to spot them. So here I have sine 48 cos 17, cos 48 sine 17. Now what you should do is you should spot these because you'll see in both parts they're going to have the same angle. So here I have, take a pen first. So here I have sine 48 cos 17 cos 48 sine 17. So do you see the squiggles match and the lines match? So when you see that, you should think, hey, there's a formula on my formula sheet that has A's and B's. So let's look for where we have sine, cos, cosine. Sine, cos, cosine with a plus or minus sign in between is either sine A plus B or sine A minus B. Do you see that? This one has a minus sign in between, so it's going to follow the sine A minus B formula. You see that? So I'm going to write it with it. So I have sine A cos B minus cos A sine B equals sine A minus B. That's what it tells me, right? If you guys can cause yourself to not distribute that sign into that bracket ever, you will do way better than 90% of the problems. Because everyone will go here and they'll go sine A minus sine B. That's not true. A minus B is like an angle. So if this is like 60 minus 30, then this would be 30. So that'd be sine of 30. Sine 60 minus sine 30 is not sine 30. They're not the same thing. You can't distribute this in. The moment you see sine A minus B, go to your formula sheet and write out this big long formula. That's what you're going to do. So when you see a sine A minus B, a sine A plus B, a cos A minus B, a cos A plus B, you go, wow, there's a formula for that. You go to your formula sheet and you write out that long formula. If you can, instead of distributing, slap your hand and be like, I'm not allowed to distribute, and you immediately go write the long formula out, you get every one of these questions right. If you don't stop yourself, you're going to distribute and get it wrong, and every single time that answer will be there. Okay? If your question is done in like 1 second, question about it. You're like, that seems a little too easy. It is. Because people will go sine A minus sine B and get it wrong. So, what matches with A in this case? A is equal to what? 48 degrees. And B is equal to what? 17 degrees. So I can just fill that into my formula. So this equals sine of 48 degrees minus 17 degrees. I can do the work in the bracket. I have to do the work in the bracket first, right? And 48 minus 17 is sine of 31 degrees. And we can just leave it like that. Most often that's the answer. They don't even make you get an answer. If you do get an answer, you just type it into your calculator with degree mode and give it decimal, right? It's no exact values. Okay. Like I said, you spot these 48, 17, 48, 17. I spot these ones because it's pi over 3, pi over 3. So technically, I will write underneath these to help myself out. I'm going to go, okay, this is the same as saying cos squared A minus sine squared A, because I just made A be pi over 3. We agree? And then sometimes it's easier to spot a formula. Is there a formula that's cos squared A minus sine squared A? What?
2 cos A.
Yeah, so it's the cos 2A, right? Okay. So we're going to get cos 2, sorry, this would be cos 2A. And what was A in this case? So it's cos 2, yeah, times pi over 3. So your solution is cos 2 pi over 3. And that's on the unit circle. What is cos of 2 pi over 3? Yeah, but what's close to pi over 3 or close to 1?
-1.
So you see how this ugly thing could turn into -1/2? The thing with double angle identities is you could have literally just found cos of pi over 3 squared it, minus sine of pi over 3 squared it, and got an answer, right? The double angle identities actually, whether you get the double angle or the single angle, they fall on the unit circle. All right. So here we have cos 88 degrees, cos 35 degrees, sine 88 degrees, sine 35. If I feel like I'm repetitious, that means I am. So I have cos, I'm going to make 88 degrees be A, and I'm going to make 35 degrees be B. I'm going to go cos of A, cos of B, plus sine A, sine B. Is there a formula that's cos A, cos B, sine A, sine B? Or does it match? Cos plus A minus B. Yeah, cos plus sine, sine, cos. Right here. So sine, cos, cosine, sine, cos, cosine, those are sines. Cos, cosine, sine, cos, cosine, sine, coses, and then these really wacky. Because if you go, there's a plus sign in between, right? So cos A, cos B plus sine A, sine B is cos A minus B. That's the formula. So remember, when you get wonky ones like this, you're going right to your formula sheet, right? The people who do better in trig 2 are people who know what formulas are on the formula sheet. Remember, that's what I said. There's a direct correlation. So the answer to this is going to be cos 88 degrees minus 35 degrees, which equals cos 53 degrees. Now these ones match. A. So we have 2 sine, I'm making A be pi over 12. So we have 2 sine A cos A. Is there a formula that's 2 sine A cos A? Sine what?
2 sine
So here we're going to get this equals sine 2A. A just happens to be pi over 12. So I'm going to get sine 2 pi over 12. Which is sine pi over 6. I'm not going to worry about example 2 for now because we'll move it forward. We've done a lot of these ones. We did this after proofs, which is backwards. So that would be after proofs we did that. With this way.
So would you ever change sine pi over 6 into 1/2?
Yeah, we can do that. Good thought. Okay. So, there's 2 ways these can be handed to us. Well, there's 3. The first way was the way we had it, where I give you like the second half of the formula, and you have to give me the more condensed formula. You can spot for that big long cos this minus sine this is actually a formula in the formula sheet, right? Or cos squared x minus sine squared x is a formula in the formula sheet. It's just instead of x's, it's like 30 degrees. That's one way. Or we can do the reverse. I can give you a sine and a cos or a tan, and I ask for the exact value. Exact value screams, I need to go to my formula sheet and give me some things off my formula sheet, right? On my formula sheet, I mean unit circle. So exact value screams values off unit circle. Because if I don't use my unit circle, I'm getting decimals, often non-repeating, non-terminating, and those are not exact values. So I need values off my unit circle. Well, we know on our unit circle we have reference angles of 0, 35, 30, 45, 60, 90. Right? All around. But if I get anything else, I can't get an exact value for it off of my unit circle instantly. So let's look at pi over 12. It might be helpful to convert that to a degree just to see what it is. So if I go pi over 12 and I want to reduce it or convert it, I need a pi on the bottom so the pi can cancel, and 180 degrees on the top, so I keep the degree symbol. Remember, that's how we convert. We make sure that we get the sign that we need, the symbol. So I go 180 divided by 12 and I get 15 degrees. So technically I'm looking for, this is the same as saying sine of 15 degrees. Okay, sine of 15 degrees is not on our unit circle. But is there anything on our unit circle that could get us 15 if we do some operations?
We could take 30 degrees and then maybe divide it by 2 or something.
We could do 30 divided by 2. We could do double angle. What else? 45 minus 30. So often we don't want to divide, we want to multiply. So if it was like, say, 60, you could do 2 times 30 because we have a double angle identity. We don't want to divide, we want to multiply. So if it was 30, we could go, sorry, if it was 60, we could go 2 times 30, or we could just find 60. That's why the double angles aren't as helpful, because the single or the double is often on your unit circle anyways. But the addition and subtractions are very helpful, because 15 isn't helpful, but 45 minus 30 is. But there's also a whole bunch more on there that you could get 15 from, right? I could go 135 minus 120. Why would I go that route when I could do 45 minus 30? I don't know. Some people are rebels without a cause. Like going to pick their numbers. You could do any, but as long as you make sure that there's 15 degrees between them, right? So I can go sine 45 degrees minus 30 degrees. Do you see how these equal signs are very important? If you don't put equal signs, if you just go sine pi over 12, sine 15, you're making them assume that those are the same, right? You need to have an equal sign so that they know sine, okay, I'm finding sine of pi over 12, that's the same as sine of 15, which is the same as sine of 45 minus 30. If you have to actually follow through. Could instead of 45 minus 30, could I just go pi over 4 minus pi over 6 and stay in radians? Absolutely, it's the same thing. Okay, now you have to stop yourself. You're going to want to, a lot of you are going to want to go sine 45 minus sine 30 because you have an addiction to distribution, because we've made you distribute your whole life so much. Slap your hand and be like, I cannot distribute that. Because sine 45 minus sine 30 is not the same as if I go sine of 15. They do not get the same answer. If you don't believe me, go sine 45 in degree mode minus sine 30 in degree mode, and you will not get the answer to sine 15. They do not get you the same answer. You cannot distribute. So we have to go to our formula. So down here, I'm going to write the formula so I have it. That's sine A minus B, right? So if I need sine A minus B, it's sine A, and I put it in brackets. I wish those were in brackets or not. Sine A cos B minus cos A sine B. A happens to be 45, and B happens to be 30, right? If I line them up. Now, I can't do subtractions backwards. If I go 30 minus 45, it's negative 15, which is a totally different answer, correct? So watch yourself with subtractions, make sure you actually get the number you're looking for. Okay, so I'm going to fill this into this formula. So I'm going to go sine 45 cos 30 minus cos 45 sine 30. Sine of 45, root 2 over 2. Please don't keep the sine word. Sine of 45 is root 2 over 2, not sine root 2 over 2. I get people keeping the sine and the coses. No, sine 45 is root 2 over 2. I take the sine 45, I chuck it, I grab the answer, I throw it in, right? Nothing stays. And then cos 30, I take it, don't want you anymore. And then cos of 30 is root 3 over 2. Minus cos 45, rip it off my board, throw it away, and replace it with root 2 over 2. And then sine of 30, same thing. Rip it off my board, throw it away, replace it with a half. The great thing about sum and difference equations is they always have common denominators. We'll always get, if you do not have one, something is wrong. Now remembering our rules with radicals. With radicals, when you multiply radicals, you multiply coefficient by coefficient, radicand by radicand. So what's underneath the radical symbol? So my coefficient is a 1 and a 1, so I just get a 1, so I don't try anything. Root 2 times root 3 is root 6 over 2 times 2, which is 4. And then root 2 times 1 is just root 2 over 4. And then I get a common denominator of 4, so I write it. And I get root 6 minus root 2 over 4. Now you should feel completely confident in your answer, or know that you need to go back and try again. Because this is the exact value answer to sine 15 degrees. So type sine 15 degrees in your calculator, type this into your calculator, and they should have the same decimals, should they not? We should feel completely confident or sad. There's no in between. It works. Confident, not sad, right? Okay, I want you guys to try cos 165. I might do addition. I'm going to do addition. But we should all get the same answer in the end. Did you get the same? It can be out of order too. It could be negative root 2 minus root 6. It's the same problem. Okay. All right. We'll deal with tens in a little bit. I want you to go to the next page. Okay, this is the last type you can be given. So there's 2 types. Here you have to spot the formula. If you spot the formula, you have a fighting chance. So I don't even see, I'm pretending I don't see anything up there. It says find the exact value of cos A plus B. So I immediately see cos A plus B and I'm like, okay, cool. Cos A plus B equals cos A cos B minus sine A sine B. Now this is what I have to say. If people spot this and write out that formula, I now know they have about a 70% chance of solving this correctly. 70%, just doing that. Because the other 70% or other 30% are going to go cos A plus cos B and get it wrong. Okay? So if you can spot that and write out the formula, you're already at 70% chance. I'm like, they're going to get this right. Okay? There's still a 30% chance to screw up in the middle, missing something, but this is highly likely you're going to actually get this question right if you literally just write out that formula. Okay? Because you bypass the oopsie of distributing. Make sense? Okay. Let's go up here. It says cos A is 3/5. Cool. Rip cos A off, toss it across the room. I have 3/5. What else did it give me? Oh, it gave me cos B is 5/13. Rip cos B off, toss it across the room, replace it with 5/13. And then I'm like, oh man, I don't know these. So that's the other 30% of the people who will get this wrong. They actually don't know how to get sine A and sine B. Okay? You can get sine A and sine B, then immediately when you're out that formula, you're getting 100. I know you are. You're getting it right. How can I get sine A, sine B? This is going back to chapter 4. I gave you a trig ratio, and I gave you where it occurs. Yeah. Yeah. So here it says cos A sits between 0 and pi over 2. So I told you in chapter 4, the best thing you can do is immediately draw it, right? Sketch it, you will have a much better chance. You're going to get an A triangle and a B triangle. So I have an A triangle here, and it's cooked extra rice. So we have x equals 3, r equals 5. If I can get y, I have sine, right? How do I get y? Pythagorean theorem. You're also going to be able to spot this later on. Fraction F 3, 4, 5 is how it works. These are the happy ones, but we're going to do it anyways. So y squared equals 5 squared minus 3 squared. Y squared equals 25 minus 9. Y squared equals 16. And when I take the square root, I get plus or minus. So I get y equals plus or minus 4. Y equals 4 is the answer. Y equals negative 4 if you want to be specific. Cross it off and say extraneous. But it can't see here. So y would equal 4. So what is my sign of A then? Sign your resume. 4 over 5. Now I can take this sign A, toss it across the room, and replace it with 4 over 5. Now I need sign of B, but I don't have a B triangle. Can I get a B triangle? Yep. Gives me cos, which is cooked extra rice, and it gives me that it's in quadrant 4. This is my B triangle, and I always label them, because when I come back, then I can just see the A and the B, and it makes me help me out. But do you see if you have the formula down, you have a much better chance of getting this, right? Because you can see, oh, I filled in 2, I need 2, well, how do I get those 2? Draw, right? Like you can work your way through. So, x is 5, r is 13, and because I drew it, I know y is negative something. That's why drawing it is helpful, so you don't put the wrong symbol on sign. So we get y squared equals 13 squared minus 25 squared, or minus 5 squared, sorry. Y squared equals 169 minus 25, which is 144. Square root plus or minus. So y equals 12 is actually extraneous in this case. And y equals negative 12 is the solution. Because I drew it, I know it's negative 12. And I told you, if you don't draw them, there's a good chance you're getting the sign wrong. So sign of B, sign your resume is negative 12 over 13. So I can take this one out, toss it, fill it, and now I can just do my math. So I get 15 over 13 times 5, which is 65, minus negative 48 over, one of these has to be it. This is a 13. Why did I put a 5? See this here, and then I wrote a 5. And how did I know I was wrong? Because with these formulas, you will always get common denominators. And the moment I didn't get a common denominator, I said, what did you do wrong? Right? So 65. And so we get 15 minus a minus 48, which is 15 plus 48 over 65, which is 63 over 65. This one you can't check. Because it's not like sine of 50, right? So I'm telling you, first step, if you see a cos A plus B minus B, sine A plus B, sine A minus, the moment you do see that, you write out the formula. If you get there, 70% of the chance of getting it right. I see that, I'm like, ah. If I see the distributed, I'm like, it's very obvious, because you know they're done, right? You know there's no chance. You're right. All right. Here's example 6. I want you to try this one. This one's like what you were trying to do. It didn't have the formulas for. Okay. So you guys keep trying that. I'm gonna record this and do it. You don't have to look till you done it. Okay, we have cos A plus B minus sine A sine B. And then we're gonna get, this one's easier than the last one because two of these, you can get answers right off your unit circle, right? So if we go to cos of 150, what's our answer?
Negative 3, root 3 of 3.
Yeah. You guys go back and replay this time. 2601, because that was a lot of like, yeah. Very, very reassuring. Okay, and then sine at 150 is a half. So take it, toss across the room, and then replace it with a half. So at the very least, I'm at a 50% chance at this point. I don't know why I put sine x. I have to replace that. So I need to get, oh, I do have sine x. Look at this one. Sine x is negative 4/5. So close. So sometimes people will leave their answer like this because they just don't know how to get the cos. Getting the cos is the easy part. It's from chapter 4. You have to draw the triangle. You have to find the third side, right? This is chapter 4. If you're getting stuck on this, you're not getting stuck on the chapter 6 stuff. You're getting stuck on the chapter 4 stuff. So we have to go and draw it. So I have sine, I have an x triangle, and it's between 90 and 270. Okay, so it's here or here. Which one is it? It's sine negative, so it has to be this one. And if you don't know, it's sine your resume. I know that my y has to be negative because my r can't be, so if my y is negative, it also has to be in this quadrant. So this one's kicked out, right? So we're here. So we have y equals negative 4. We have r equals 5. We have x equals negative 3, because once again, it's a 3, 4, 5. It has to be negative because it's
In the quadrant 4, 3.
it's in a quadrant that is not 2.
Yeah.
Yes. Okay, so it has to be negative. So we need cos of, this is my x triangle. I need cos of x. Cos of x equals x, cooked extra rice, negative 3/5. So take cos x, toss it out, and I get negative 3/5. And so I'm going to get 3 root 3 over 10 minus 4 over 10, which is 3 root 3 plus 4 all over 10. So I'm giving you a few questions. Yeah. Snowing. Just, if the window was closed, you'd know it's still snowing. Or positive. Thanks for all your helpful hints. Okay, so there are quite a few in here. But this lesson is the one that people, I need you to do more questions of, because I'm not joking. When you see cos A plus B, you have to immediately think formula. Cos A minus B, formula. Sin A plus B, formula. Sin A, formula. Gotta go on my formula sheet, gotta go on my formula sheet.
If I can get that step done, most of you will get it, every single question right. It's just going to the formula sheet. Because people will instantly distribute and then it goes badly real quick. And by real quick, I mean it's a 0. The moment you distribute and don't use the formula sheet, you got a 0. It's a really easy marking question, but it makes me sad. So it's not good.